Easier than...
Okay.
Okay, so hello. This is a demonstration of the Distech 2100 replacement kit. So what we're looking at is we have taken over the Distech enclosure. There used to be a printed circuit board here, and we removed that and replaced it with our hardware. So what we see is an Arduino, which is the controller. This has the code that is running the system. This is a speed sensor circuit that detects the speed of the motor. So here we have the motor. It's currently running at 250 RPM. And here is a gear on the end and a little pickup that has a magnet and a coil in it. And each time one of the gear teeth passes, it puts a little signal on the wire, which comes out here. It's amplified by a differential amplifier, and then it's turned into a square wave and sent to the controller. And
I'm sorry to interrupt. Where's the trash can?
oh, it's under the sink.
Okay, good.
Sorry. So the speed comes into the controller, and the controller has a PID control loop inside it. And then the speed the controller chooses, it sets the speed by varying the width of pulses that it sends out to the motor. And those are put out on this wire, and they come over to this board on that connector there. And then this board has an amplifier that turns that 5-volt digital signal into an 18-volt signal that turns this IGBT on and off. And that IGBT controls 130 volts that then goes over this wire out to the motor. And then this here is part of the power supply, and it has two regulators, one for 18 volts and one for 5 volts. The 5 volts supplies the power for the Arduino controller, and the 18 volts is the supply for the amplifier circuit that turns the IGBT on and off, and for the differential amplifier circuit. And then this here is the power supply. It's a bit over-engineered at the moment. It can be shrunk to be much smaller. But this is the main coil right here, the transformer. And that's the main power switch there. And then that's the controller chip down there. And that converts the AC to DC. Okay, so for a little demonstration, right now the software controls the speed by setting a value in the program and then uploading that value, compiling the program and uploading the whole program to the Arduino. So we just changed it. It was at 250 RPM and now it's at 50 RPM. So you can see it changing there nice and smoothly. You can see that it started very cleanly and came up to speed. And so that is that's the system.